Friends, this question from software testing quiz 1 question paper 2024 July 7th. Okay, each single vertex with in degree is x and out degree is x is a ddpath. So in degree x, out degree x, right? Very important. In degree, out degree. So for example, in degree is id, out degree is od. So both are same value. X must be an integer in the dd paths. dd means definition paths. Definition paths. In the above statement, what will be the numerical value of the x? The dd paths are related to structural path testing. So structural path testing. So in the structural path coverage criteria, we use ddpaths, that is definition to definition paths, that is ddpath, definition to definition path. Okay, so what is a ddpath? In a set of vertices, please remember not edges, that is set of vertices. The set of vertices represented with integer numbers, right? In a control flow graph, a set of vertices in a control flow graph, so it satisfies the some conditions. If it satisfies these conditions, there are 5 conditions. If it satisfies the 5 conditions, it is a ddpath. Okay, what are these 5 conditions? These are very important, friends. Please remember, and you get question from these dd paths also. A single vertex in a control flow graph, a single vertex with in degree is 0. And second one is same, a single node or single vertex. Single vertex or node, you can call it as node also. Node with out degree is also 0. Okay, and the third condition, so same, a single vertex or node with in degree, id means in degree, friends. Id in degree is greater than or equal to 2, or you can remember or any one condition, only or out degree greater than or equal to 2. It satisfies all the conditions. In degree equal to 1, and friends, please remember, and here if it is 1 and condition, if it is 2 or condition, you can remember like this. And out degree is also 1. In degree 1 and out degree 1, both you have to remember. For end equal to 1, right? So for end 1, in degree out degree both are 1. For or anyone, in degree out degree greater than or equal to 2 for our condition. So you have to remember this one. And next, fifth condition is maximal chain of length is greater than or equal to 1. 5 conditions must satisfy a path, a single path in a control flow graph is called a dd path. Okay, is called the dd path. This is very important, friends. You can expect questions from this topic also. Okay, for example, so the first condition is single vertex of in degree is 0. So for this node 1, so Please remember here not related to edges, only vertices or nodes. So that is node 1. 1 has a no incoming edges, right? No incoming edges. That is in degree 0, right? The edges of in degree 0. That is, this is the source node or initial node. Source node or initial node. So first condition satisfied, right? First condition satisfied. And our degree 0. So for example, node 6, final vertex. There are no edges going out from 6, right? No in this direction. So there are no edges in the going in outward direction. So for that means the control flow graph must consist of start node and end node. Okay, this is the terminal or sink node. Sink also we call sink node or terminal node. Second condition is also satisfied, and third condition is here. So this condition is our single node with in degree greater than or equal to 2 or out degree greater than or equal to 2. Here node 2, that is decision node. Node 6 is not a decision node. Node 2 is only decision node. Here in decision node, in degree greater than 2, right? Greater than or equal to also there. That is equals to 2 also possible. That is, these are decision nodes. These are decision nodes. That is, your control flow graph must consist of start node, terminal node and decision node. Any one is okay. In degree greater than or equal to 2 or out degree greater than or equal to 2. The next one is a single vertex or node with in degree equal to 1 and out degree is equal to 1. So in this graph, so 5 is in degree 1, right? Only one edge is coming, one arrow is coming to, one edge is coming to node 5. So for this in degree is 1, and for this in degree is also, out degree is also 1, right? So for example, node 5 and node 4 are the examples for this fourth condition. It also satisfied condition number 3, 4. Next one is maximal chain of length greater than or equal to 1. That is, the chain length is equal to 1 is also possible, right? So that is, this is the maximal chain of length. This is the max chain. So that is 3, 4 is the max chain. Means, so chain means an edge between two decisions. I think an edge between two decisions. Here 2 is a decision node. 2 is a decision node, and the chain is maximal chain, means we cannot extend. The chain cannot extend further. The chain cannot extend further. Chain means an edge between the two decision nodes, or the chain is a straight edge. The chain is a straight path. The chain is a straight path, that is no decision points. No decision nodes. There is no decision nodes in a chain. The chain means a straight path, that is 4 to 3 there is an edge, right? There is no decision nodes in between. 3 to 4 is a chain, and the straight edge, there is no decisions or branches. No decisions or branches. Here 4 to 6 is not a chain. Why? 4 to 6 is not a chain because it here at node 6 merging is possible. merging of two edges, that is the path from 4 to 6 edge 5 to 6 are merging at the node 6. So this is not a chain. 4 to 6 is not a chain, 5 to 6 is also not chain. Here 3 to 4 is a chain because it is a straight path, there is no decision points, so that is there is no merging points also, there is no merging or no splitting of them. If you execute the first node in a chain, you are guaranteed to execute all of them in a order. So if you execute the node 3, that is the statements at node 3, and you execute the statements at the node 4 also. For example, here at the statements I equal to 0 and I, for example, I plus plus. So if you execute the node 3 and you execute the node 4 also, there is no branches splitting, merging is not possible in between the chains. So 3 to 4 is a chain. So 3 to 4 is a chain, it is also a maximal chain. Maximal chain means the maximum length of the chain, it cannot be extended. So 3 4 6, is it possible is a maximal chain? 3 4 6 is not a maximal chain because at node 6 there is a merging point. At 2 2 3 4 is a maximal chain. 2 3 4 is not a maximal chain. At the 2 is a decision node, right? Decision node. So that is here the splitting is possible. The statements, the program execution, it flows and splits into two branches. So it's not a maximal chain. So 3 to 4 is the maximal chain and it also a maximal chain, it cannot be extended. So all these 5 conditions must satisfied by this control flow graph. So the path is a decision path. So in the question, in the above statement, what will be the terminal value of x? We are checking the conditions of the decision paths, right? So which condition is this one? Both the values are similar. So here vertex in degree x and right and out degree x, and means equal to 1, and equals to 1, right? So here and equals to 1 and r equals to greater than or equal to 2. So and that is out degree, both with similar values, that is its value is x. That is this condition. And means fourth condition, this one, fourth condition. So its answer is 1. Okay. Okay friends, if you like my videos, please like and subscribe my channel, and thank you for watching.